Hi, I'm Pranav Bharadwaj. Every financial team faces this problem. The bank says one thing has happened and their financial records are slightly something different. So someone has to sit manually and go through hundreds of transactions and figure out where the actual problem is coming and what's missing. You know, it is very slow, and this is where the razorpay briefs points at. You know, it's the verification, not the generation. This is the biggest bottleneck in the financial operations right now. So I have built an agent which does this reconciliation automatically. Now, here comes the AI agent. This ran on 69 plus bank transactions and 80 ledger entries. It is synthetic data but built with 9 different real world failure patterns baked in exact matches, settlement delays, rounding the difference from bank fees, typos in reference numbers, invoice, split across two payment, duplicate bookings, and genuinely unmatched items like bank charges that have no ledger counterpart at all. The 85.5% transaction were matched automatically. Out of those, 100% were actually correct. I know that because I held out the true answer key and scored against it far. So this number isn't self-reported, it's checked. The remaining 14.5% weren't forced into a wrong match. They were flagged, and that's where AI comes in. For everything the matching engine couldn't confidently resolve, it hands the case to an LLM. Now here I'm using the Grok LLM. I've attached the Grok API key to this agent and ask it to actually reason about it, not just print no match. Look at this one. This one is flagged duplicate. The two ledger entries have the same date, amount, reference, and counterparty. The agent doesn't just flag it, it explains that it looks like the same transaction booked twice and recommends confirming which entry is real before it's either gets cleared. That's a judgment call, not a template. This is the actual functioning making that call. It's real API request, and if there's a call ever fails, it falls back to the rule based explanation rather than silently hiding the failure. I hit that fallback myself a few times while building this. A depicted model name and a blocked request, and fixing those taught me more about this how API actually behave in production than a clean first try would. Now, here comes the pre-scenario breakdown table. This part I want to call out specially. I deliberately made this hard on myself. Some of the transaction pays here are the same merchant closed its amount with 3% of each other, and I intentionally made the reference numbers not line up between the bank and the ledger so the engine couldn't cheat with an exact match. That's the difference between a demo built to look good and one built to survive the actual test. So the scoring is honest by design. The matching engine never sees the correct answers, only the scoring step does. After the fact, separation is what stops from being cherry picked. Now, this is a working prototype, not a finished project. I want to be upfront about the gaps. The synthetic data has the clear signal than the real bank statements would. Real narrations would be are messier, OCR errors, inconsistent formatting, and many more. The matching thresholds are tuned against the dataset specifically. So production for version would need those recalibrated against real transaction samples. And right now, this closes one loop back to ledger. The natural next step is expanding to its settlement and tax line matching too. Now I built this because I understand reconciliation problem. I did build a similar system to it, but it was for GST reconciliation. Now this thing actually helped me to push it further, you know, actually give a real-time accuracy and an AI agent, an LLM, which not just flags but also gives out reason what went mismatch and why. This actually helped me push this project more further and understand it in deep. And actually built a data set which actually works on this. Now that's the project. Thank you for watching.